We in the last class stopped with the topic which is drift velocities derivation. Now we'll do with the second part of the same topic, which is mobility, and its symbol is mu. Now what do you mean by mobility? Mobility means something which is related to movement. Now what particles are moving here, or what scenario we are considering? The electrons motion, right? Or I can say electrons as mobile charge carriers. Why I am saying they are mobile? Because they are moving. So mobile charge carriers. So current conduction in any conductor is due to the mobile charge carriers, which is electron in the case here. Now when electric field is applied, what happened? The electron drift is happening from negative to positive terminal, which I took in the last class, guys. How and all etc. I took it by drawing circuit diagrams. Okay, so what happened in the electric field is applied, the electrons is drifting from negative to positive. That means they are increasing in mobility, the motion is increasing, right? And that means more drifting, and this drifting capacity of electron is indicated by a term called mobility. Right. So what happens when the electric field is increased? That much increase in motion of electron, or I can say that much increase in their mobility. I hope it is clear. So the basic equation for mobility is amount of drift velocity when you apply amount of electric field, or it is known as ratio of drift velocity by applied electric field. Now we'll put the expression of drift velocity which we learned earlier, small e capital E tau by me. Right, so can I cancel the term? Yes, I can cancel E, so that it becomes E tau by m. So guys, in this video you might hear some disturbance, some work is going on in another my neighbors' homes. I'm extremely sorry. I can never stop it. I cannot ask them to stop doing their work so that the video recording can happen, and I'm extremely sorry if you are feeling it as a disturbance. So that's why I'm trying to increase my volume. I hope my volume will be much more audible than the other disturbance. So let's move on to the topic. So mu will be equal to E tau by m. That is a final expression for mobility. This topic or this expression is asked for 1 mark questions for examination point of view, and it is usually a part of question, that is subtopic or sub question for another major question. Clear? This is a small derivation. Clear? Let's move on to the 3 marks questions which is usually asked, that what is the relationship between I and Vd, that is current and drift velocity. Now so guys, I want to mention another thing also. This chapter around again 80% of it are numerical circuit questions. So we'll do a lot of questions. That time please don't mind that it is little bit tough, etc, etc, and almost all the questions cannot be done. We'll do a lot of pattern questions, and example of them will be given to you as a homework. So what is the relationship between I and Vd? What is the drift velocity and current relation? We will derive an equation for it. So we will start with the circuit. Suppose this is my conductor. I am connecting a supply to it, and this is voltage source V, and electric field will be in this direction. Suppose area of cross section of this conductor is A, and current electron is moving in this direction, current is flowing in this direction. Hope you understood. Okay, the length of the conductor is L. Right, I is from positive to negative. Suppose I write here I. This much clear, and electron is moving in this direction. Now, what will be the volume of this conductor be? Volume is area into length. This much clear? Now we are going to consider a small volume of this conductor. Suppose this is a small point. I am going to project it like this. Right, this is a small volume, not this one. This is a conical. I am going to project it. Right, this volume I am going to consider. Right, and that volume or a single unit of that volume is going to have n number of electrons. That is, a small unit or a small unit volume, 1 unit of volume has n number of electrons. Suppose this is a scenario, right? So V volume will have how much electrons? So V volume will have n into V, or I can write n into AL right? V volume will be having this much electrons. I hope this much is clear. So if you are, so V volume has how many charge? How much charge will be there? You know, Q is equal to N into E, right? I hope this much is clear. N into E. Here N is this much number of electrons of the, not this section. Clear? Here let's make this one as, I will make it as dark so that it will not be confusing. Right? That means there are dark N number of electrons in unit volume. So V volume will be having dark N into V amount of electrons. So in place of V, I just represented A into L. This much is clear. And you asked what is the charge in that much of volume means. Charge is Q is equal to NE, that is here N is small n, right? So I'm going to represent this N in this form. That is for the entire volume, it will be number of electrons will be N into AL and charge multiplied so that I get total charge. So Q is equal to N E A L. I just rearranged it. This much clear? Now the electrons are moving from one end of the conductor to another end, right? So how much distance it requires to travel the entire conductor will be time is equal to distance by velocity. Which velocity I have to write here? Drift velocity. So the distance is length and velocity is drift. Now what is current? I is equal to Q by T. We just represent, or from the above equation, it is NEAL divided by L divided by VD. Now you can cancel LL, you will get an expression NEA VD. So I is equal to NEA VD. This is the relationship between current and drift velocity. That is, when current increases, drift velocity also increase. This much is clear. Right, now we will do a small problem with this equation. Now the question is, a wire of diameter 0.02 meter contains 10 to the power 28 free electrons per cubic meter. For an electric current of 100 ampere, the drift velocity of the free electrons in the wire is most nearly. You are asked what is drift velocity, that is VD. But you are given some current, so that means that is your I is given. So how would you solve it? It's very easy by using the above expression. You will write I is equal to NEA VD. Right. So I can also write VD is equal to I divided by NEA. Right. How much is current given? It is given as 100 ampere. And number of electrons is given as 10 to the power 28. What is the charge of electron? It is 1.6 into 10 to the power minus 19. What is area here? See, it's a wire. And what is usually area taken as? It is cross-sectional area. So this is wire, means this part is your area, right? So this is a round. So what is cross-sectional area? It is pi r squared, right? So you will write it as pi r squared, means you require radius, but you are given diameter. So it will be half of it, that is, it is 0.01 meter. So r squared becomes 0.01 whole square. This much clear? Now you just have to substitute pi value as 22 by 7, or you write it as 3.14. You will get the answer as 2 into 10 to the power minus 4 meter per second. Calculation should be done by you guys. Right? So you will get a value of drift velocity which is 2 into 10 to the power minus 4 meter per second. That is option D. This much clear? Now we'll go for the next topic, which you know from your I think 9th or 10th class, which is Ohm's law. So what do you mean by Ohm's law? I hope you remember that if you have a conductor, you connect it to a supply, right? The voltage is given through it by V. It generates a current I, and the current flows through this conductor also. So as the voltage increases, the current also increase, indicating voltage is directly proportional to current. This is your Ohm's law. In order to remove this proportional sign, we include a constant term which is resistance. That the Ohm's law's equation is V is equal to IR. Right, this much you know. It's a very simple term or a very simple equation which you have been learning from the last 3 years, I believe. So V is equal to IR. So the constant term which you are including is known as resistance, right? This is a condition which you will learn is constant, or this law is universal, but there is some conditions where this is not universal, right? So where are those conditions? We'll go for it. There is the next subtopic is limitations of Ohm's law. I'm not going to write it as a heading, guys. You can write it by yourself. That is limitations of Ohm's law, right? Now, what is basically we told that when voltage increases, the current is supposed to be increasing. This dependency occurs only when the temperature and any mechanical stresses are not changing, right? The temperature is constant and there is no variation in another properties of the material, but sometimes it can change, right? So we are going to do, or when we are going to consider 4 types of devices or materials where the Ohm's law doesn't follow in the same way. So the first term or the first type of material is we are going to consider very good conductors. That is good conductor. In case of a very good conductor, the Ohm's law is not followed, right? So what happens is, you know, for Ohm's law, what is a graph? If this is V, this is I, the graph is supposed to be like this in the case of Ohm's law, right? But what happens in the good conductor condition is it is not like this. That is, there is a non-linear way. It might be going slightly like this, then it goes like this. That is, there is slight change from the linear path, or there is a non-linear relationship between I and V. That is, when current flows from, for more time, what happens is when current is flowing through for a very good conductor for a lot of time, the material gets very heated. When temperature increases, that means the nature of the object changes. When the nature of the object changes, the resistance changes, right? When the resistance changes, obviously the voltage and currents ratio is also going to change. This much is clear. So for a good conductor, the Ohm's law is not always true. At some point, it will undergo a non-linear form also. Clear? Now the second type of material is called diode. You might have seen diodes in your circuit. It's just like a black. It is just like there will be a like. So this is entirely black with one silver band on it. It's a diode, and you can even make a radio using a diode and few resistor and a transistor. Anyways, so in diode also the graph between voltage and current is not linear, and also there is a reverse current flowing also. That is, when you consider the graph, it will be like this, right? And this is known as forward biasing. That's when this voltage is increased and current is also increasing. This is forward bias condition, and there is a graph like this also, that is reverse bias. That is minus current and minus voltage. This portion will be learned in your, I think, 15th chapter in your NCERT, but I will give a slight idea. That is, forward biasing means this is the diode symbol. When I connect the positive side of the diode with positive, negative side of the diode with negative. This and all I will tell you later on. This much you have to have an idea that diode is having different type of VI graph. And the diode, if it is connected to reversing this source, this becomes negative, this becomes positive. This is known as reverse biasing. This much idea, just get to know that the diode is not following Ohm's law. This much detail you will learn after a few chapters. Clear? There is a chapter called Semiconductor and Devices. In that chapter we'll follow this. Clear? Right. Now let's move on. And the third type of material which doesn't follow Ohm's law is thermistor. Thermistor. In case of thermistor, look into the graph, guys. It is like this. Why it is so, etc. you will learn in degree level. That much is not required. It just looks into the graph, right? This is I, this is V. You see a portion AB here, right? I'm marking it as AB. This portion is known as negative resistance region. What? negative resistance. Why I am telling this as negative resistance region? See, when the voltage is increasing, the current is decreasing in this region. When voltage increases, the current is decreasing, right? Voltage is increasing, but current is decreasing, right? This much is clear, right? Now, this type of region is known as negative region, right? Thermistor is a device which is used temperature resistance. Later on you will learn on higher studies. Right. Similarly, there is a fourth material where the Ohm's law doesn't follow, which is gallium arsenic. That is, sorry, gallium arsenic semiconductor device. Its graph is like this. When you plot like this, right? So you will see a negative region here also. See? No, not this one. Consider this and this, not this one. Okay. This much region, when voltage increases, the current is dipping, so this is a negative region, right? So this is a voltage current graph for gallium arsenic. Clear?